Hello everyone, this is take two for this video. If you were checking for it before and it wasn't up, I'm sorry, there was some technical difficulties, but in this video I'm going to be going over graphing polynomial functions, okay? And when we're graphing these functions, it's not going to be a super precise, all right? It's going to be more of a sketch. So you see, we kind of talk about that there. So the sketch is really based on two things. The first thing is the end behavior. So we went over this in the previous video. So if you're still not sure on end behavior, go watch that video. I'm not going to go into it super in depth here, but basically what you need to know is how to fill in this table, okay? So if your degree is positive, all right, that means your graph is finishing going up on the right. So I'm going to draw those arrows. If your graph is negative, that means it's finishing going down on the right. And then the other thing we know is that even degrees means they're facing the same direction. So either both down or both up. Odd degrees mean the arrows are facing opposite directions. So we have an arrow going down and an arrow going up, okay? And you need to be able to recognize, which of these cases it is based on the equation, okay? The other key feature that it's going to be based on is the zeros, all right? We talked a lot about the zeros in the quadratics unit. The zeros are when the graph crosses the x-axis. They're also known as x-intercepts, okay? And so the reason this is helpful is because a function of degree n can have at most n zeros. So you can kind of figure that out from there. The y-intercept is going to be the constant of the function. Okay? That's not really going to come into play. So I just want to get to the graphing, all right? So the way that we're going to be kind of giving you the graphs, we're going to be giving it to you in factored form because we haven't really taught you how to factor something like this yet, and that's going to take a while. So when it comes to graphing right now, you're just going to be graphing it like this, okay? So a couple things. So first you need to figure out the end behavior. So you need to figure out what is the leading coefficient and what is the degree, all right? And so the leading coefficient will always be the number out in front. So here you can see there is no number out in front, but that means it's positive 1. And then the degree, okay, so clearly the degree is 3, right? But if it was only given to you in factored form, the way that you would figure out the degree is that the degree, it's basically the number of x's you have in your function. So since we have 3 x's there, that means our degree is 3. So our graph is odd positive, okay? So since it's positive, that means it's finishing up on the right. And since it's odd, it has to be opposite direction. So the one on the left is going down, all right? So we know our function's gonna end like that. So the end behavior on the right, it's up, on the left, it's down. Then we want to do the zeros, okay? So if you remember how the zeros are gotten, when your equation is set equal to 0, you want to find out when does each parentheses equal 0, right? And so you've got all of these forms, right? And what it ends up being is just kind of the opposite. So the first one is x equals -4. The second one is x equals -1, and the third one is x equals 1, okay? So that's kind of how you find the zeros. So once you find the zeros, you want to put them on your graph. So we've got a dot at -4, we've got a dot at -1, and we've got a dot at 1. And what you want to do next, multiplicities, we haven't talked about that yet. So for this one, there's none. We'll talk about those in a second. The final thing is y-intercept, all right? So the y-intercept is really the only other point we want to find. It's the kind of easiest point to find because all you have to do to find the y-intercept is plug in 0. Because remember, the y-intercept is on the y-axis, so that's where x equals 0. So if you plug in 0 for all these points, the reason it's kind of easy is because then you don't have to really do anything. They all just go away, right? You're just left with the same numbers that you started with. So we have 4 times 1 times -1, which is -4, all right? So we know our y-intercept is -4. And so once you have the zeros and once you have the end behavior and you know the y-intercept, literally all we're doing from there is filling in the graph, okay? So the way that the graphs look, they're kind of beginning going up and down. So you've got to go up, you're going to go through the first zero, then you have to come back down, go through the second zero, go up again, and then you finish, all right? So I'm going to move this arrow over there. It doesn't have to look perfect, all right? I mean, mine clearly doesn't look great, but this is basically what the graphs are doing. They're just curving back and forth, if you remember from our key features graphs yesterday. So you're just curving back and forth, going through each zero until you've gone through them all, and then you finish at the arrows, all right? And so that's it. And so you can check on Desmos and actually type this in, all right? And you can see, you know, do you get something that looks like this? You should, all right? So the last kind of new thing that we're going to talk about, and then we're going to finish with 2 more examples, is multiplicity, all right? So multiplicity means how often the zero occurs. So this is a regular zero, right? This is what we just talked about last time. This would be a zero at -1. So you know your line is going through -1. Then we could have a multiplicity of 2. This means there's an exponent on the x plus 1. So that means the zero actually occurs twice. So you still have that zero at 1, except now what's going to happen is instead of your line going through the graph, it actually bounces off of it, okay? And it kind of like makes the quadratic, which is the graph of the x squared. So that's, you know, something to pay attention to. If it's a 3, multiplicity of 3, that's kind of like the x cubed. So remember the x cubed is like the slide, so it kind of slides as it goes through it. So that this would mean that the 0 at -1 actually occurred 3 different times. So this is kind of how this looks, all right? So looking at this graph right here, leading coefficient, again, it's just 1. All right, now the multiplicities do affect the degree because now this x occurs twice. So when we're counting our x's for the degree, you got to count that one twice. So this is like 1, 2, 3, 4, right? So this is a degree of 4. So this is even positive, that's +1. So we know both arrows are going to be up. All right, like that. In behavior, that's what I just drew. So even positive, we know both arrows are going to be up. When it comes to the zeros, so this is going to give us a 0 of 1. That's going to give us a 0 of -3. That's going to give us a 0 of -2. Okay. Multiplicities, we do have one multiplicity. It's the x minus 1 squared. So at our 0 of 1, we got to make sure that we're bouncing off of that. Now we want to find the y-intercept. Again, we just plug in 0. So all the x's basically just go away. So we've got -1 squared times 3 times 2, okay? And so the multiplicity does actually affect the y-intercept because now this number is being squared. So -1 squared, that's going to be 1 times 3 times 2. So our y-intercept is going to be 6. So the only reason the y-intercept is helpful is just, I don't know, giving you an extra spot that you know you have to go through. And I forgot to put my zeros before. So we need a 0 at 1, at -3, and at -2. So we know we're coming down like this. So I'm going to go through my 0. I'm going to curve back up. I'm going to go down. Now remember, this 0 we have to bounce off of, and then we finish up. So this is kind of my graph. All right, it's kind of what it looks like, kind of like a W. Okay, so you can see here, you needed to bounce off that in order to hit your arrow, right, finishing up. So they kind of play in together, all right? So that's that. Last one, I'm just going to go over 2 things real quick, all right? Number 1, this is what it might look like if you do have a leading coefficient. So this leading coefficient is -0.5. The degree, so here we have a multiplicity of 3, so that one counts 3 times. This is like 1, 2, 3, 4, 5. Okay, so this would be a degree of 5 because there are 5 x's. Then, so and odd means we're finishing down on the right and we're finishing up on the left. And so to finish this, all right, you can kind of do it your zeros. All right, the second to last thing that I wanted to go over, this 0 right here. So it's kind of obvious that this 0 is -3 and that this 0 is -6, but there was a lot of confusion about this in class. This means that there's an x equals 0 as your 0. All right, there's nothing else in the parentheses, so x just equals 0. So anytime you see an x outside of the parentheses by itself, that's going to be giving you a 0 of 0. So you have 0, -3, and 6. Oh, wait, no, that's not 6. That's -6. Sorry. So we can put those down. And so this actually is the y-intercept right here. So we don't even need to figure out the y-intercept. The y-intercept is 0. We had one multiplicity of x plus 3 squared, or sorry, cubed. So we need to kind of curve when we go through that -3. So now we want to fill in the blanks. So this arrow was too far to the right. So this is going to be going down. All right, then it's going to go curve through here. Then it needs to go back down through there and finish. So again, kind of wonky. Your graphs don't have to be perfect, all right? They just need to be a rough sketch of what the graph should look like, okay? So there's 3 examples. Hopefully I didn't go through it too fast. If you are watching this video because you missed class and you have questions, just come to office hours. I'll help you out, or just send me a message and I'll try and answer your questions, all right? Make sure you get your take-home quiz done. If you have any questions, let me know, and have a great day.